Okay, time is 12:30, so let's begin here. Assignment number 6 is due on November 30th at noon. Are there any questions? Okay. We left off last time in the notes on page 3. So we were talking about how we can basically embed our R code inside of LyX documents. And the way that we do that was through the help of the knitr package in R. Now, in order to put your R code in the LyX document, you have to use an ERT, these evil red text boxes, or a LaTeX code box you could call it instead. And inside this LaTeX code box, you need to use what's called a chunk. It's an odd name. I didn't pick this name, but they're called chunks. And anyway, so just to give you an example, we're going to take a look at this file shortly dealing with my serial data. Here is a LaTeX code box, and right in here is a chunk. Okay, so let's look at the basic syntax for a chunk. You begin with 2 less than signs. Then you have the chunk name. This chunk name can include spaces in it, although the author of this package, she suggests not to do that. I don't even try it, so I haven't looked to see if there's any problems that can occur. And then after the chunk name, you have a comma and various options that might control, how the R code is executed, what actually appears in the corresponding PDF that is produced, and so on. You again end with, or you don't again, but now you end with 2 greater than signs, and then you have an equal. Now remember in R itself how you can use a x less than dash to give it an assignment, and you can also use an x equal to give an assignment. And so essentially that's what this equal sign is doing, is making an assignment so that wherever you refer to this chunk name maybe later in your document, you get the same information back as you would the first time that you executed it. Now inside the chunk here, this is where you just write out normal R code. To tell LyX that you're done with the chunk, use the @ symbol. Okay. Now you can actually get away with not actually using a chunk name. I don't recommend doing that. knitr will actually pick a chunk name for you if you don't put one there, but I think it's a lot more descriptive if you actually use a chunk name, so I always do it myself. Let's see now. So there's a number of different options, as I said, that you can put with a chunk. A nice comprehensive listing is in the course in our book, but also at this website here. I guess I kind of jumped ahead there. Chapters 5 through 9 of the book describe these options. Okay, so to help explain how to use knitr with LyX, we're going to go back to the serial data. And the way I constructed this document is more like a report rather than my lecture notes. So you're not going to see me use a larger than normal font size, for example. And also I'm trying to organize it more in terms of paragraphs rather than using bullets like I try to use in my lecture notes. The corresponding LyX file is this one right here, although I think I actually, at the end of it, I actually have 2.1.5 because that was the actual version of LyX that I used to construct it. It works just fine in 2.2 of LyX. Also, all my R code that's actually inside the LyX document itself is also in a separate R program. The reason being, as you will see through using LyX and knitr yourself, LyX and knitr do not give you helpful error messages when you do make a programming error. And so what I have found it to be always useful is that outside of LyX, I have a separate R program which I type my code in, make sure it runs, and then I insert it in a chunk in LyX. I highly recommend that you do something like that. Okay. So here's my document. I originally had written this document assuming that we hadn't actually seen the serial data before, so that's why you'll see some introductory serial data stuff in this. Now, my very first LaTeX code box is the one that you see right there right now. I'm not going to talk about it here because these actually control some global options that concern how your code and output looks in LyX. We will come back to it later. But if you please take note, every line here begins with a % sign. And what does that mean in terms of LaTeX?
It's a comment.
It's a comment. So what I've done is I've commented over it so that when I run it and when you run it, these options are not run because I want you to see what the default behavior is of knitr. Okay? So, let me actually pull up the PDF. Go away. So this is what the actual PDF looks like after I compile. I just compile it like normal. And so you're going to see it structured in terms of it has some basics of how to use knitr. And then I have some stuff about how you can change the appearance of the code and output, how you can change the content of what's actually printed. I talk about plots, I talk about tables, and so on. So that's how this is all structured. Let's begin first with, I want to be able to read in my serial data set. So I can do stuff in R and in LyX itself. And this is what the end result will be. If you notice here, the syntax will be automatically color-coded for you, depending upon, of course, what the code does. So like usual, I read in my data using read.csv, and then I use the head function to look at the first 6 observations. What you will notice is that knitr removes all the normal leading command prompts that you would see in R. Like in all my lecture notes, you see a greater than sign. It automatically removes it. Also, and I don't know why it does this, in any output, it automatically puts a double pound or 2 pounds right next to each other. One advantage of doing it like that is that, let's say if you were to copy and paste this directly from the PDF into R, you could do that, and the fact that the output's there is not going to affect anything because R is going to recognize it as a comment. I don't necessarily agree with all the defaults that is used in knitr. And I know that this isn't showing up very well on the projector there. At least from my angle, I can't see it very well. But can you see like a gray background for where the code and output is? That is also the default. Okay, so let's see how we can do this in LyX. Simply, I'm going to name this chunk read in data, for lack of a better name. And then I just put in my R code. And I put an @ symbol to say, hey, I'm done. That's it. And so what LyX is going to do when it compiles it, just to make sure this is clear, it's going to send the stuff to R. And then once it gets the output, it's also then going to go to mictech. And then everything's going to be nicely knit together, you could say, where you have your normal text, then you have the R code and output. Normal text again, and so on. Okay, so in the end, it's not really too difficult. Yes?
How does it deal with like errors in your R code?
We will talk about that shortly. Basically, it will try to continue to compile the document like
Will
normal.
It have like a warning thing
Yeah.
for the output? Okay.
Yeah, so you'll see like some warning messages. But, when I said before how the error messages are not very good, I said that a few minutes ago. What I'm talking about is in terms of why LyX and knitr didn't behave properly together rather than why R didn't necessarily work. Okay? Okay, so also, let's, if you remember with the serial data, I need to adjust it for the serving size, the sugar, fat, and sodium. So, again, a new chunk, I call it change var, for the lack of a better name. And I have the same code that we've seen before. So here's how I change the sugar variable. And then you can see here's the head again. And let me go over here. Oops. And here's the corresponding R code and output. Just so that you can see it once in class of how I can compile this stuff, I'm going to compile it here. And if you can see, look in the lower left-hand corner here. You're going to see some information about the normal compiling that you would normally see with LyX, but also you'll see some stuff with R. So I'm going to compile it. Kind of quick there, but you see something called like R script. Well, if you remember, I showed you last time, there's a program called rscript.exe. Basically, that's what LyX is doing, is calling that rscript.exe to actually run the code. The code in the output then comes back to LyX, and everything's nicely knit together. Okay, so just to review too, well, how did I do this? How did I adjust how did I adjust the variables for the serving size? Well, if you remember, what I did was I took the sugar grams, we'll talk about sugar grams per serving divided by the number of grams per serving, and then for the first value, which is Kellogg's Razzle Dazzle Rice Krispies, what that means is if you actually look at the data set, there's 10 grams of sugar, the serving size is 28, and then if you do 10 divided by 28, you get 0.3571. Now, to get that, I had to actually manually do this all myself. It would be nice if maybe R could automatically do these calculations for you within the document. Before I show you how to do that, let me just mention something here. So what's this kind of equation that we see here? What's it called? A display equation, okay? And so let's say that I come in here, I'm going to copy that. Now, notice here you see stuff that looks like regular text inside the equation. Notice it is not italicized like you would normally see. How did I get that? Well, sorry, I'm kind of going out of order here. How did I get that? Well, let's insert a new equation. So I come down here in the lower left-hand corner where I have my little toolbar, set display mode, and I have my equation thing come up. And now if I were to type normal, you can see how everything's italicized. Well, how did I unitalicize it or ask LyX to treat it as normal text? Well, I highlight it, come down here to various options of how the text should be treated. And if I come here to normal text mode, and that's how I did it. Then, and notice how you have those see the little corners there? That means I am in that text area. So as long as I'm in there, if I want to, I can do a space, for example. So like space, space grams, space per, and so on. Now, once I exit by hitting the right arrow, now look at what happens. Oops, I guess I didn't exit it. Now I'm back to the italicization. Okay. Well, okay. So I was getting a little ahead of myself before. So I've copied this whole equation here. I actually went in the equation box and I copied it. Now look what happens when I paste it outside of the equation box. Now you see the actual LaTeX code that's used for it. So that thing that we did to have the text be treated as regular text rather than maybe a variable or something like that, well, what was the LaTeX code that went into it? /textrm. And notice how that's all in a bracket, curly bracket. Now the reason why that's important is because I want to be able to have my R stuff be inside my equation so that I can automatically get that 10 out of my data frame, automatically get that 28 out of my data frame, and automatically have R calculate 10 divided by 28. So to do that then, again, I did a LaTeX code box. And so what I'm going to do is essentially type the equation again. So there's that text RM. Notice how I'm leading with a double, can't talk today, a double dollar sign there, because if you remember in LaTeX, that's how you do display equations. And then if I come over here to the equal, you can see that I have a /SEXPR there. This is knitr stuff. That /SEXPR means S expression. Remember how R's origin comes from the S language? That's why it's called. That's why you see S there rather than R, a capital R. And then simply, anything inside the curly brackets for that S expression will get sent to R. So in addition to using a chunk, I can do stuff like this too to have R executed. So what that's going to do is find the first element of that sugar_G variable. Then I will divide by the first element of the size_G. And then I use S expression again to actually do the division itself. So that when we take a look at the document, you can see this is what I originally did by manually typing out the numbers, and this is what I did by actually having R execute everything. It's exactly the same, except for some odd reason, I don't know why, I chose not to round the number. How would you do that? How would you fix that? Very simple. Just type, because it's just, you're using, essentially just using R, use the round function. And then that will be exactly the same. Any questions? Okay. Now also, suppose I want to have some kind of calculation done or something extracted from a data frame and put the results not in a display equation, but just essentially in regular text itself. Well, if I had an equation, I could just do the equation like normal with using a single dollar sign to do an inline equation. Or in this case, what I want to do is just simply state, well, how many observations are in the data set? Well, there's 40. So I can come over here and simply insert a LaTeX code box, do S expression again, number of rows of serial, and it pulls out, does the calculation, puts in 40. That's it. Okay. So let's look at how we can maybe control how the code and output, how it appears in that actual PDF document. And here are 3 options that you can use with your chunk to make things look nicer. Number 1, I can use prompt to equal true. The default is false. And what that simply means, if there would be a command prompt at the beginning of a line, it will now actually put it. Next, comment equal NA. Again, if we look at this output here, we see all these double pound signs. Well, to have those removed from the output, I just put NNA instead as my option. And then lastly, to remove that gray background, I can say background equal white. So if we take a look at then the LyX code, or take a look at LyX, suppose I want to actually calculate the mean and standard deviation for every shelf corresponding to the sugar variable. So I name the chunk mean SD, and here are those three options. Here's my code. I use the aggregate function, as you've seen in a previous assignment, where I say formula equal. I want to aggregate sugar by shelf in the serial data using the function mean. And if we take a look at the result, we can see I no longer have the gray background. I do have the command prompts, and everything looks nice. Now, why do I do this? It was because this is usually the standard that's used in textbooks. It's used in journal articles for displaying R code in output. Okay. And you'll see me actually do this in my lecture notes as well. Now, in the actual assignment, assignment number 6 that we talked about last time, you will note that go away. Okay. There's my pen. Your R code and output should be formatted in the exact same manner as my lecture notes. Okay, so that will give you a hint then of how to do that. I will give you some additional information shortly. Unfortunately, I got ahead of myself again. I'll give you some additional information shortly about how to make it even a little bit easier to do it than what I just did there. I want your R code and output to be displayed like in my lecture notes. The key difference is don't make the font larger than the normal size because it's not lecture notes. Okay. Okay, let me make sure I'm not forgetting anything. Well, what about changing the font size itself with a particular chunk? How can you do that? Well, there is a size option. Okay, makes sense. What doesn't make sense, of course, is that it doesn't say size equal 14, 14 point or size 14 font. Instead, and this is common in LaTeX, unfortunately, we have words to mean certain sizes of fonts. So normal size is what I have been using so far, but you can get an idea of through the names of those other sizes what could happen or how big it might be. And how do you actually determine the actual font size? How do you determine if the actual font size is satisfactory? Well, try a few of these names, see what happens. Find a font size that is appropriate. So one of the times where you do want to change the font size is that at times, you can get into a problem where the code and output is actually extending too far to the right. It's in the right margin or even off the page. Well, by simply changing the font size to something smaller, that might be a quick fix for a particular problem. Also, when you're doing like lecture notes or if you're doing an actual presentation where you do want to have the font size larger, then it's helpful to use some of these larger font size names. So just to give you a quick example of, in this particular case here, so what I decided to do was estimate in the ANOVA model where I have just one factor. The factor is shelf, and my response variable is sugar. And so I just simply say size equal large to actually estimate then that, to blow up the size just to show you what could happen. And you can indeed see that things are bigger. Okay. Now, I think this might be a good time, too, to talk about, well, how would you estimate an ANOVA model in R? Well, there's a few different ways. Here's one. I'm going to put the results into mod.fit. I use the function AOV for analysis of variance. And then for my formula argument, just like what we see with the LM function, I have my response. And then I have my factor itself. Now, shelf is numeric, 1, 2, 3, 4. To have R recognize that this is actually a factor, means a qualitative variable, I had to actually tell it was a factor. We've seen this in other notes before, so I say factor shelf. And then I actually print off then the estimated parameter values. So let me actually go over here. Okay, given that, tell me how to write out that analysis of variance model. I will write the first part for you. Let's write it as a cell means model. Mu hat is equal to what? So mu meaning the response mean. I'm going to give an estimated value for it. What comes next, based upon what you see in the output? Or is it too simple?
0.25.
Yep.
6, 8.
Okay. Then what?
41.58.
Are you sure?
Maybe not.
Did I give it away by saying, are you sure? But I appreciate you volunteering, both of you volunteering to say something. I'm going to write it like this instead. Does writing the model out like that look familiar? I hope so. Maybe not. That's one way to write it.
Could you also use like an indicator function?
Exactly. I'm going to call it y hat versus mu hat. I'll explain why in a second. So you could write it out as like this. Where x2 is the indicator variable, representing if it's level 2 or not. I'm kind of writing this out fast, so I guess normally I would take a greater care in how I'm writing this. So that would be another way to write out the model, or use the indicator variables instead. Two ways. Exactly the same model. This way is the way that you often see it represented when you do analysis of variance. So like a course like Stat 802, this is how you typically would write out a model. This way is more the regression model way of writing it out. This is what you typically would see like in a course like Stat 870. Hopefully in Stat 821 you've seen both of them. They're equivalent. And one of the reasons why I wanted to point this out, because sometimes it can be confusing to students who are new to statistics, is that an ANOVA model is exactly the same as a regression model. It's just a special case. An ANOVA model is a regression model with qualitative explanatory variables. That's it. Okay? Any questions about that? It's maybe beyond our class here, but I think it's a good time just to point that out. Okay. So, one of the things I was saying about regarding font size is it's maybe nice to change the font size when you run into problems with stuff going off into the margin. And this can be a problem. How else can you fix it? Well, one way in R that you could use to limit the output itself in terms of how many characters it can go over is to use the options function and say width equal maybe 60. So that in the output itself, you are always limited to 60 characters from left to right for one particular line. The problem with doing that is that that's not going to help you with the R code itself. And the R code itself could just simply go right off the page. So what's the fix? Well, you can add an option to a chunk, and it's called tidy. Tidy equal true. The default is tidy equal false. I think in more recent versions of knitr, this is actually, I think the option has changed, or I'm sorry, the default has changed. Because I know when I was preparing for this class, using some old lecture notes that I had, my code wasn't running right. Things were going off the page. And I found out, oh, now the default for tidy is changed. So if you by chance, if by chance you run into some of my LyX documents where stuff's going off the page, maybe I forgot to change it there. Okay? But tidy equal true. Well, why is it called tidy? Well, you know, I like to think of my mom, and my mom would always say, keep your room tidy, meaning clean, but it doesn't have to be perfect. And so tidy here in this context means, okay, it's going to nicely make your code look nice. It's not going to be perfect, but it's going to make it look relatively nice. And along with the tidy equal true argument, you need to also issue some options for tidy. And so in a separate option, you're going to need to say tidy.opts for options equal, and then you have to put it into a list format. So again, we're talking about R here. This is R code. And in that list format, one of the arguments that's helpful is width.cutoff equals 60. And what that's going to do is something similar to what options does. But notice my wording here. It causes R to attempt a line break after 60 characters. So if R finds a good place to stop a line and go now to the next line, it's going to do that break. Here's an example of where the break would not occur. And you can still have stuff going more than 60 characters. You might be thinking, gosh, these are boring details. Trust me, I've run into many cases where I needed to know this level of detail. So let's say you create a data frame. We'll just call it X for the lack of a better name. So X gets data.frame. And inside of X, I'm going to have X1 equal 1, comma, X2 equal 2, comma, and I'm going to keep on going. I'm going to have a lot of different things there. One of the key things to note here, I have no spaces between everything. Okay? If you execute this in R, that would be fine. If you do it here, it will work too in LyX. The problem is that LyX and knitr won't know where to make the break. And so since there are no spaces at all, it will just run it off the end of the page without saying, okay, let's move X2 down to the next line when it prints it. Annoying, yes, but this also encourages good coding practices to actually use spaces in one's code. Okay. Now, you could set all these options in every single chunk. But you might be thinking, oh, do I have to do that? Is there some way I can have like global options where this is going to be used all the time? And the answer is yes. And to do that, you use this here. Okay. Let me go back up here. So if you remember, I had some stuff that was commented out. So I'm going to remove those comments. And I have a new chunk, and I typically have this at the top of any LyX file where I'm using knitr. You'll see this at the top of all my lecture notes. And I have a chunk usually called set options for the lack of a better name. Include equal false. This is a new option that we have not seen before. What that basically means is I don't want any of the R code and resulting output to actually appear in my document. Because all I'm going to do here is just set some options that I want to affect future R code and output. That's it. So include equal false. And the knitr package is arranged differently from what I had ever seen any other package arranged before when I first saw it in 2013, I think it was. And that there is an actual object in the package itself called options chunk, or OPTS_chunk. And it is actually a list. Again, we've talked about lists. It's very important that you get comfortable with lists. One of the components of this list is called set. And actually this component is a function itself. That's weird. I had never seen that before, that someone actually creates a list where one of the components is a function. And so by whether or not that's really necessary or not, I don't know, I guess maybe I disagree with the author of having to do something like this, but this is what he did. And so inside then the function itself, that's where you can declare these options of what you want your code and output to look like. So there you see my prompt equal true, comment equal NA, background equal white, tidy equal true, and the one that I forgot is the tiny, the tidy.opts. I would have normally put that in what I have, I guess, on page 4 of this document. Where can you see an example where I have done that? Well, here is my graphics lecture notes. So we just got done with the graphics section. These are the actual, this is the actual LyX file that produced the PDF that all of you have. And you can see at the very top, I set my options. And in this particular case, I do include the tidy options. Also notice size equal large as well. Now there's another line of code here, and this is also in, I guess we can just look at it in here. There's another line of code as well. This is our code for options. Options equal quote, end quote. I'm sorry, continue equal quote, end quote. I guess I do have the answer there, darn it. I was going to ask you, what does that mean? Anyway, if you notice in R, when you reach the end of the line and you still have some stuff to go down to the next line, R puts a plus sign there. Well, if you want that never to actually appear, well, use this options. Options continue equal, and then it just simply puts a space. That's it. I think that looks cleaner when you actually present code in a document. So that's why I've set it. So now, if I were to run this, now you can see how everything, and I know that's kind of small, everything is formatted essentially the way that I want it. Okay? Any questions? Let me go over here. So as I said, that this OPTS_chunk is actually a list. And of course, with any list, if you do names, you see the components of the list. And so that's what I did here. Notice they're set. So if I actually issue the command OPTS_chunk, $set, you see the actual function itself. Now, there are other ways to control the code and output appearance all at once other than using what I just did there. There are actual themes that you can use, similar to like PowerPoint or Beamer. There are themes that you can use. Well, there are themes that you can do with your code and output. You're welcome to take a look at some of those on your own. I give you some information about how to find out more about them. Okay. Now let's talk about next the code and output, the content that's actually printed into the PDF. How can you control that? Well, there is an argument called eval. And what eval allows you to do is say, hey, only run maybe line 1. Don't run line 2, or vice versa. So if I say eval equal, then the line number of the code. And what I mean by that is, let's see now, where is that? Oops, went too far. I guess I don't have an example there, but that's okay. I'll come up here. So if I put eval equal 1, only that first line will be evaluated. If I did -1, everything but line 1 would be evaluated. Now, why is that important to know? Well, there are times, especially I know when I write out my lecture notes, where all I want to do is show the code. And I don't want to have any output at all displayed. I want the code to be, nicely syntax highlighted and stuff without the output. Okay, well, this allows you to do that. Say, don't evaluate certain lines of the code. The include argument, or option, I should say, asks, well, do you want to include the corresponding output? If you say false, no out. I'm sorry. I said that wrong because we've actually even already seen include. When I do include equal false, that means none of the code, none of the output is actually printed. And again, that's what I did with those options. Then lastly, what I was actually trying to say, echo equal false. What that will do is don't echo the code into the PDF. Just put the output itself. Echo equal true is the default, so the code and the output goes to the PDF. This is important in particular cases when you want to actually maybe just present an automatically generated table from R without seeing the actual code that's done. Also with a plot. You'll see examples of me doing that shortly. Here's an example where I just wanted to print an ANOVA table only. And again, how did I do that? I did echo equal false. So after I estimated the model using the AOV function, I used the summary function, and the result from the summary is the ANOVA table. But you didn't see any of my code that went into it. Okay. Let's next talk about plots. So you might expect to do plots just like normal. And this is the actual plot that I want to generate, which we've seen before. It's that box and dot plot that we saw before. Now, the key aspect here is within the chunk, whenever you're doing a plot, that plot by default is not displayed until you get to the last function that will cause some change to it. So if you remember, when we actually first did this in the graphics section, if I were to execute this segment of code, what would happen is my graphics window would pop up and you would have the box plots. Now you might be thinking, okay, then right here, right after box plot, I should have just the box plots. Then when I do the strip chart code, then I'll have the box plots plus the dot plots. That doesn't happen. Instead, what happens is what you want to happen. Only after the last change to the plot is done, that's where the plot by default is inserted. Okay, let's take a look at the corresponding code. So here's my chunk, box dot plot, tidy equal true, some tidy options, and again, here's my code. Now, just to show you that indeed, by default, the plot is actually inserted after the last function that makes a change to it. I just threw in some additional R code here that really had no meaning at all. Just pull out a sugar value for a particular observation. And as we saw, the plot is inserted, and here R keeps on running. Okay? Now, let me make this bigger again. There are a variety of different options, as you might expect. right now I'm using fig.show equal as is, meaning it's going to do what I just did there. But maybe you might want to hold the plot until the end of the chunk. Well, you can use the hold argument. Now, there's a number of different ways that you can control the size of plots in your document, and this is often something you have to fool around with until you get something that looks good. And we have very self-explanatory options, such as fig.width, fig.height. The numerical values are in inches by default. You can also align the figure as well, right, center, or left. So here's let's take a look at this next plot. So what I have in this particular case is I'm showing you now how to more formally put a plot into a document. Especially if you end up writing a journal article at some point in your career, you're going to need to have your figures to float. We've talked about floating before, where LaTeX itself will choose an appropriate spot to actually put the figure in your document. And there's many other more formal writing situations when you need to do that too. And so what I've done here is put what's called a parallel coordinate plot in a float box in LyX. Does anyone know what a parallel coordinate plot is, by chance? This is one of my most favorite plots. It's great for plotting multivariate data. So let's briefly talk about it. So this is for the sugar, fat, and sodium values. Let's focus on sugar here. Imagine a situation where you want to rescale all the sugar values, all 40 values in the data set, to be between 0 and 1, so that the smallest sugar value is going to be 0, the largest sugar value is going to be 1. And so imagine a y-axis here that has 0 at the bottom, 1 at the top. Now where you see these lines crossing the sugar, you can say a sugar axis there, that then corresponds to the relative value for a particular observation. So the observation that the smallest sugar value is right down here. The observation of the largest sugar value is right there. Everything is appropriately scaled in between. So if you had one that was somewhere halfway between the smallest and the largest, then that would maybe be right about there. Okay? Now the same thing is done for fat. All the fat values are scaled between 0 and 1. Same thing is done for sodium. And what's really cool about this kind of plot is that each observation then, the same observation, so for observation 1, its sugar value, its fat value, and its sodium value are all connected by a line. So we can see, for example, this cereal that had the smallest sugar value also had a relatively low fat value and also had a relatively low sodium value. And I was able to do this plot in a way so that I was able to color code it by shelf number, and so that's a shelf number 3 cereal. And so what this allows you to do with multivariate data, meaning multivariable data, is it allows you to see trends. So one thing that you'll notice is that notice the red lines have higher sugar values. Shelf 2, which we've talked about in the past. If you want to know more about parallel coordinate plots, you can take a look at my notes for Stat 873, where I talk about it in more detail. Okay, now that we know the interpretation of this plot, let's look at how we actually got the plot then in here. Okay, so I inserted a figure float. Again, insert, let's see, there we go, float figure, okay. LyX automatically prints figure 2 there. Here's the caption that I typed myself. I put in a label there so that I could reference that figure. Notice here's the reference right there. And then I put the LaTeX code box, which contains the par chord chunk. I control the size of the figure, and this is the key part right here, equal false. in a more formal setting, you wouldn't want to see the actual R code that went into this. You just want to see the plot in the figure itself. So don't echo it. Yes?
What's the purpose of the chunks having names? Can you like reference a previous chunk?
Yes. Yes, you can. And while it doesn't happen much, there may be some times where you would want to. I will show you later in the notes here. Like I said, you don't need to put a name there. I find it useful from an organizational tool. Also, what you'll notice is that, and I should have pointed this out before. Notice you see figure here. I didn't create that folder. LyX and knitr actually created that folder for me. And if I click on that, notice the names of these plots here corresponding to the chunk names. And in fact, there's one of the figures. I think, you might be wondering, why is there more than one box plot? Why is there more than one par chord plot? I think it happens to do because I've run this code and I've compiled this document a number of times using different versions of LyX, and I just forgot to delete them out. But that is one thing to think about, is that if you have some very complex plot that takes up many megabytes of space, you might want to go back in there and delete out some of the plots periodically if needed. Okay. So also fig.align center it. And then I just have my actual code that was used to create the parallel coordinate plot. I'll just briefly go over it. The actual functions in the MAS package, which stands for Modern Applied Statistics with S, I believe. It's actually the name of a famous book. That's kind of old now. Similar to what we saw before, I need to create a vector that contains all my colors that I want. We did this like with, I think, some of the scatter plots. And then par function, MAR, standing for margins. I want to take out some white space that would normally be in the plot, so it looks nice in my document itself. The actual function that does the parallel coordinate plots, par chord. In the X argument, I put the actual columns that contains the data that I want to plot. The color of every observation, shelf.color. And then I add a legend to it. That's how I got my plot. Now you can include, if you always want your figures to be 7 inches by 4.5 inches, you can include that information at the beginning of the program where I have the options for each chunk as well. Okay. Are there any questions? Okay, we have then reached the end of the class. We will continue in this section next time. We may get to the next section as well, so be prepared for that. Okay, that's it for today.